So we've already done a little bit of this with just basic distribution, kind of what we've already been looking at, something like this. We have like -2 times 8y cubed plus 15y minus 3y squared. This is pretty much multiplying polynomials, right? We're just distributing out at -2 on anything. So we have -2 times 8 would give me -16 y cubed. -2 times 15 would give me -30y. And -2 times -3 would give me +6y squared. So this is technically multiplying a polynomial, and honestly, a lot of what we're going to be looking at today is going to be fairly similar. We're just going to be taking more advanced cases of distribution. So let's look at something a little bit, applying our power rules that we talked about yesterday. So here, once again, our first distribution, we take the 4 and the 3 to give me 12, and then the x squared times, that's technically an x to the first. Using our power rule we talked about yesterday, says we're going to add those two powers together to give x cubed. And then on the second one, we have a 4x squared and a -7 to give me -28x squared. So like I said, just using our power rules to distribute onto multiple terms here as opposed to the single terms we were dealing with yesterday. Okay. And then what we're going to look at, what we've done a little bit of work with before, but we kind of want to officially kind of go over it. What happens when we have two binomials, meaning two-termed expressions being multiplied times each other? So pretty much what we have to do is two distributions. I have to distribute the 3x onto both of these. I have to distribute the 4 onto both of these. There are a lot of ways to do this. There are a lot of techniques. The two that I've seen that are most popular are what's called the FOIL technique. The FOIL standing for first, outside, inside, and last. So here, we're just going to take these and multiply through. So my first here would be 3x times 8x, so that's 24. X squared, because those both have a power of 1 on them. The outside terms would be 3x times +1. So that would be plus 3x. The inside terms here would be -4 times 8x. That's -24. Sorry, -32. Pardon me, 32x. And then lastly, we have -4 times a +1. So that's going to leave me with -4. So then from here, we're just going to combine any like terms we have. So we have a 3x and a -32x. So 3 minus 32 is going to give me -29x minus 4. So that's kind of one way to work out this expression. The other way that some people like is breaking it down into like a box. Let's make it a little bigger. Okay, so where we write our expressions along here, so we have 3x minus 4, 8x, +1, and then we just multiply everything through in the boxes. So 8x times 3x, it's the exact same information. It's just, it's a little easier to kind of see what are all the multiplications we have to do. So -32x, 3x times 1 is 3x, and then 1 times -4 is -4. And then we have these like terms. along this diagonal. So we're going to combine those. Get the, once again, it's the exact same final expression. 24x squared minus 29x minus 4. Just this collects it in a slightly different way that some people like to, it's very nice and organized. So these are kind of the two ways to kind of set this up. So yeah, feel free to pick either one. Doesn't really matter. And like I said, when we say first, outside, inside, last, it doesn't necessarily have to be exactly in this order. You just need to make sure that you do all 4 multiplications. If you wanted to do, first, last, outside, inner, if you want to do Floy or like Lafoi or whatever, you really could do it in kind of any order you want, just making sure that you have to cover all 4 multiplications. Okay, let's look at just one more of these. Okay, so just once again, I'm going to tend to use FOIL the most just because that's what I'm the most familiar with. It's not me saying that it's better than the other ones. I'm just the most familiar with it. So working that out, that's going to give me 3x times 8x cubed. It's going to be 24x to the, remembering there's a power here, so 1 plus 3 is x to the 4th. Outside term here, 3x times negative 9x squared. It's going to give me negative 27x cubed. Inner terms here of minus 4, positive 8 gives me negative 32 x cubed. And then my last term of minus 4 and minus 9 gives me positive 36x squared. Okay. Once again, we look for any like terms here. I have common x cubed, so we'll combine those. And the minus 27 minus 32 add together to give me minus 59 x cubed plus 36x squared. Now we have just one, slightly higher powers. Question on anything so far, anybody? All right. So there will be times when we have something maybe a little bit more advanced, meaning that we have something like this. Which is, let's say we have a binomial and a trinomial being multiplied together. Now the problem here is that FOIL doesn't cover everything, and we can't have an acronym for every single combination or multiplication. So what we're going to look at here is really all we're doing here is just to make sure that this piece, this 2x, gets multiplied onto all 3 terms. And this negative 3 gets multiplied onto all 3 terms. That's really all we need to make sure. So let's do that. Let me do the 2x first. So 2x times x squared would give me 2x cubed. 2x times negative 2x would give me negative 4x squared. And 2x times positive 1 is going to leave me with a positive 2x. Then, in blue, we're going to multiply through our minus 3. Once again, just doing it on all the terms. So minus 3 times x squared gives me minus 3x squared. Minus 3 minus 2 gives me positive 6x. And minus 3 times a positive 1 gives me minus 3. Okay, so just going down the line, combining our like terms. I like to start off with the highest power. I don't have any other x cubed, so we can just bring that down. We have a minus 4x squared, minus 3x squared, leaves me with a minus 7x squared. plus 2x plus 6x leaves me with plus 8x. And then we don't have anything else to work with the 3, so we just have minus 3. So when we have some slightly more complicated expressions, it's really just making sure that, we distribute this term onto everything in the second polynomial, and we take our second term and multiply it times everything in the second polynomial. Okay. Questions on this, anybody? All right. That's it for 5.3, fairly straightforward stuff. Next, we're going to look at 5.4. We've done addition, subtraction, multiplication. Last one we're going to go is division of polynomials. Which once again, we've technically kind of done division of polynomials, like when we had stuff that looked like this. What did we do? Well, we technically divided both sides by 3, but the way we dealt with that is we broke it up into individual pieces. We said this was 4x over 3 plus 12 over 3, and then we would just simplify as needed. So 4/3 x plus 4. This is technically dividing polynomials. This here is a polynomial of 2 terms. So if we're dividing by a single term in the denominator, remember we call that a monomial, that's how we're going to do it. We're just going to split it up. So if we have something like 15x squared minus 12x plus 6 all over 3x, if this is my first division, what we're just going to do is break this up into each individual division because we just have a single term in the denominator. So we have 15x squared over 3x minus 12x over 3x plus 6 over 3x. And we'll just go through and divide each of these terms, remembering that when it comes to powers, division means we're going to subtract the powers. So on my first one, 15 over 3 leaves me with 5. And x squared divided by x to the first is going to leave me with an x to the first.
Your screen is invisible.
Minus 12 over 3 is going to leave me with a minus
Professor?
4. And here, these are both x to the first, so it would technically leave me with x to the 0, but x to the 0 just means that we cancel out.
Professor?
Hey, Professor. Can you hear us?
Did he mute us?
6 over 3, that's going to cancel and leave me with a 2
I believe so.
up top.
I think we have
And
to
since
just
we don't have
message
any
him.
x's to cancel, we're just going to leave that x in the denominator.
We got his attention.
And muted you.
Oh, so he's noticed.
Oh. Almost realized, yep.
Can you hear us now, Professor?
Yeah, there we go. Sorry
Oh,
about
okay, great.
that. My
Because your
apologies.
screen was frozen, so we couldn't really see what you were talking about.
Okay, wait, is it frozen now?
No, now we can see everything, but basically the second part, so the second equation that you started, we couldn't see it all while you were talking.
This one right here?
No, from the beginning.
Oh, this entire thing.
Yeah.
Right. Okay, all right, cool, great. I do apologize. My internet has been going in and out, and it has been an issue. I'm trying to solve it, but yeah, it's been a thing. Okay, so I'm going to start back from the beginning. My
Thank
apologies,
you.
folks. Looking through this. Once we have an expression like this, what we want to do is just like we did here in the previous term, we're going to separate everything up over the denominator. So we're going to break this up into 3 pieces. 15x squared all over 3x minus 12x over 3x And lastly, 6 over 3x. Okay, so working this out, we have 15x squared over 3x, so the 15 over 5, sorry, 15 over 3 leaves us with a 5. And x squared over x to the first just leaves us with x. Technically, if you want, you could write x to the first power. Next one, we have 12 over 3. Negative 12 over 3 gives me a minus 4. And these are technically both x to the first, so that would leave me with literally x to the 0, but x to the 0 just means that the term canceled out. And then lastly, we would have plus 6 over 3 would cancel to leave me with a 2 up top. And since we just have x here in the denominator, and there's nothing to cancel it out with, that's just going to stay here in the denominator. So here we have division with a monomial. We basically just break it up into its individual pieces and divide it all the way through. Questions on that, any?
So this would be the final answer. Like if, for instance, on our homework, this would
Mhm.
be the answer. Okay.
That's it. Okay.
Professor, will the numbers always come out whole, or will they be sometimes like, all these numbers are kind of divisible by 3, but will it ever be 17 over 3 or?
Sure. Yeah. Yeah. There could be some weird kind of. Yeah. Let's do one of those. Let's do something like. Let's do the following. So it's kind of just, once again, the first thing to do is just split it up into our terms. So we have 5m cubed over negative 5m minus 9n squared over minus 5m. And then lastly, plus 10m over negative 5m. Okay, so once again, going down the line, 5 divided by negative 5 is going to give me a negative 1. And m cubed over m to the first would leave me with minus 1 m squared. Next two terms, negative 9, negative 5. So these don't simplify, but we do have that a negative and a negative is going to give me a positive 9 over 5. And you can write this two ways. You either write it as 9 and then put the m, so m squared over m would be m on top. You can just write it as 9m all over 5, or what we've done in the past is we just write this as 9/5 times m. Both of those are valid. You can plug either one into the homework. Both of those are okay. And then we have last one, 10 divided by negative 5 would leave me with a negative 2. And here the m's just cancel out. So here is our final expression. So yeah, if the numbers don't fully simplify, that's fine. You can either write it as a fraction multiplied at the front, or you could just leave it as leave the variable up top and any denominators you have in the bottom. Both will be accepted.
Thank you.
You're welcome. Okay, any other questions? All right, so this is what happens when we're dividing through by a single term, a monomial. What we're going to look at next is what happens if we divide by a polynomial, which is what if we have like 2x squared plus x minus 10 all over x minus 2. So the problem here is that we can't split this up over the denominator because I have like 2x squared over x minus 2. We can't just cancel out single terms like that. We can only cancel it out if it's the whole thing. Oops, if it's the whole thing going into that. So we're going to have to do a different technique for when we have a polynomial in the denominator. And the answer is we're going to go back to long division. So we have something like, we're going to go x minus 2 into 2x squared plus x minus 10. We're going to literally break this up as a long division problem. So what I kind of want to look at here is, this is going to be silly, but breaking down a numerical long division problem step by step and working out, okay, how do we do this? So the first step when we do numerical long division is we take the number and we say, all right, doesn't go into 1, but we can go into 10. And 3 goes into 10. Technically, the way you do it is you go 10 divided by 3. That goes in 3 times, right? So mirroring that over here, what we're going to look at here is how many times does x go into 2x squared? So we kind of write that off to the side. We're taking 2x squared divided by x, which would leave me with 2x. So we divided that in. On the numerical side, next step would be we multiply this out. 3 times 3 gives me 9. In the algebra, we have to take the 2x, but we are going to have to distribute onto this entire expression. So we have 2x times x gives me 2x squared. And 2x times negative 2 gives me negative 4x. Okay. So next step here, in numerical form, is we would subtract down. 10 minus 9 gives us 1. Now, here's the thing. Technically speaking, we're going to do the exact same thing, which is we're going to subtract this down. But I find that students tend to make mistakes with the sign, specifically on the second 2 terms, because these are always just going to cancel out. So here's what I'm going to recommend doing. You don't have to do this if you find it too confusing, but it will keep your signs a lot nicer, I find, overall. Instead of doing subtraction, what I'm going to do is I'm going to change that to addition of the opposite signs, which we can always do. If you have 6 minus 4, that's the same as 6 plus a negative 4. And that's all I'm doing. I'm changing this subtraction to addition and just flipping the sign. Why this is nice is that now it's very easy to see we have x plus 4x, so we come down and get 5x. Whereas before, when we had this here, students might have, a lot of students would say, oh, that's, well, that's an x. You're kind of mentally doing addition, so a lot of students would have written this as like a negative 3x, which would be incorrect because we're actually doing a subtraction. So it's, again, not a mandatory step, but one I like to do, and I'm going to continue to do with these problems, is I'm going to change that subtraction to addition and just flip the signs of my expression. These first 2 should always cancel out to give me 0. And then the second 2 terms will just add on down and get 5x. All right, so over here back in numbers, the next step of long division is we drop down the 5, and then we go 3 goes into 15, 5 times, and then we just kind of keep going. 5 times 3, 15. We keep going until we hit 0 or something.
Are you writing something down right now?
Oh,
Oh,
am I
okay,
done?
now we can see it. Sorry.
So, a quick question: is it just the screen? Is my voice still updating?
No, we hear you. It's just sometimes you were doing the math problem or the equation, and then 5 seconds later, we actually see what you wrote down.
Okay, weird. It's weird that my voice is coming through, but the picture is not. I'm not sure what that's caused by. Check something real quick. Yeah, okay. My internet seems to be doing all right. All right, we'll just kind of, please feel free to alert me if that happens, and I'll just kind of keep going back. So, train of thought. So, okay, back, we did the numerical part here. So we're just going to continue the same thing, which is we're going to drop down the minus 10. And then just go from here, which is we're going to take this x and divide into that first term. So we're going to take 5x over x, which would just leave me with 5. So we have a plus 5. And then we're just going to distribute that into my expression. So 5 times x would leave me with 5x. 5 times negative 2 leaves me with a negative 10. And then here is where we would normally subtract, but I'm not going to subtract. I'm going to add, oops, wrong thing. I'm going to add the opposite sign. And here we add down, and we're left with 0. So this here is my expression for the quotient. When we divide this out, my final expression here is 2x plus 5. Okay. Questions on this? Okay. We'll do a couple more examples, really kind of get into this stuff. One thing that happened with long division, which is, so in this case, we divided evenly because eventually we got to 0. When it came to numerical long division, the question happens, so, here 3 goes into 9 3 times, 0, drop the 7. 3 goes into 7 twice, which would give us 6. And then we have this thing where we would subtract down, get 1. 3 does not divide into 1. So there were kind of 2 ways to go. There was the decimal route, or when we were first doing long division, we would just go talk about remainders. So we'd have 32 remainder 1, or the other way you could write this is in a fraction form, 32 and 1/3. When it comes to variable division, when we're doing long division, these are going to kind of be our 2 forms that we end up working out, because we can't really do decimals with variables. So let's do an example where we don't divide fully evenly and just kind of talk about how we deal with that. So let's say we're going to look at x minus 3 into 3x cubed plus x squared minus 2x plus 5. Okay, so term by term, x into 3x cubed. So here we would cancel out and be left with 3x squared. That's what goes up top here. And now we're going to multiply into the function and distribute. So 3x times x gives me that 3x cubed. And 3x squared times a negative 3 leaves me with negative 9x squared. And once again, we are technically subtracting here, but I'm going to add the opposite signs. So in the first 2 terms, once again, we cancel out the first two and get 0, and then we get x squared plus 9x squared, which leaves me with 10x squared. Bring down our term here, we have minus 2x, and now we're just kind of continuing this same system. Taking x into 10x squared
Didn't you say it was 3x cubed?
Yes, that was a 3x cubed.
Okay.
Yeah, so we're taking, right now we're taking the x into the 10x squared. So 10x squared over x leaves me with 10x. Then once again, we're going to distribute that in. So 10x times x gives me 10x squared. And 10x times -3 leaves me with a minus 30x. So adding the opposite sign here, it's going to give me -2x plus a 30x. That's going to leave me with a 28x. And then we're going to drop down the 5. Okay, so last one. We're going to take our variable x into 28x. And you see me kind of doing these on the side. I don't necessarily have to see this work right here. If you can kind of do these divisions in your head, which some of you might be able to do, I don't necessarily have to see this work if you don't need to. I just kind of do it because it makes it very clear exactly where I'm getting all of these numbers up top. So the x cancel, we're just left with positive 28. And then one more time, distribute that in. So 28 times x gives us 28x. 28 times -3 gives us a negative 84. And one more time, last step would be subtracting, but we are going to add the opposite signs. So 5 and 84 leaves me with a positive 89. So x cannot go into 89. You know, if we have 89 over x, we couldn't simplify that because there's no x in there. So this is going to be my remainder. So with a remainder of 89. And in your homework, what you'll have is there'll be two ways you'll be asked to write it. One is with a remainder, so you'll put in your first expression in the box. So 3x squared plus 10x plus 28. And then you'll have a remainder box, and then you'll type in your 89. So if you have a remainder box, that's fine. That's how you type that in. The other time is you'll be asked to write it as what's called a quotient plus remainder form, where you'll just be given a single box, and here's how we do the quotient plus remainder form, which is we're just going to write this answer here, 3x squared plus 10x plus 28. And then the remainder portion is going to be plus my remainder of 89 over whatever my original expression we were dividing by. And once again, you will be told which one of the two forms, oops, wrong way. One more time, there we go. You'll be told, you know, the homework will be very, very clear which one of the two forms it's asking for. Okay. Are there any questions on this so far?
Professor, will there be examples where what we're dividing, like what's inside the box, for example, it says 3x cubed, will it ever say 3x negative cubed?
No, we're only going to be dealing with polynomials dealing with positive powers.
Okay.
So short answer is no. The one thing we will have to contend with, though, that causes a little bit. Before I move on to the next question. Any other questions on this example here?
I just have a question. What does it say over the box, like above the box?
Oh yeah, sorry, yeah, my pen got. It was quotient plus remainder.
Oh, okay. Thank you.
Okay. Let's look at one more. Um, Okay, so there's one little thing that you have to do with these, and it's something you inherently do with numbers. It's just when we're talking about variables, it's a little bit harder to keep track of. So outside, obviously, we have our x plus 4. And then inside, what we have here, if you notice, if we're counting down, you'd have an x cubed. Normally, you'd have an x squared term, right? The problem here is that that hasn't been listed. So what we need is I'm going to put in a little placeholder of just plus 0x squared. And then I'm just going to write, kind of go down, plus x minus 5. And the reason we have to do this is just like anything else. Like if I wanted to write the number 405, I couldn't just say 4 and a 5 next to each other, right? We need that 0 there to kind of give me a space in between the 4 and the 5 to tell me that we're dealing with a 400. We need the exact same thing when we're dealing with this variable division, which is I want to make sure that when we're dividing out, I have every single variable counting down, so we're not skipping over anyone. So anytime we have, just be careful when you have your expressions, that if you're starting at a cubed, what's underneath your division bar needs to be every single power counting all the way down. Once we get past that step, though, everything kind of works exactly the same. Here we're taking x into 3x cubed. So it's going to leave me with 3x squared. So 3x squared times x leaves me with 3x cubed, and 3x squared times 4 leaves me with plus 12x squared. And here's kind of why we needed the placeholder, because if this hadn't been there, it would have been, plus x minus 5. These here are not like terms. So we can't combine those in any way. This is kind of why that placeholder needs to be here, so we just have a term to combine with. Okay, once again, normally we'd be subtracting, but I'm not going to subtract. I'm going to add, oops, let's do that. I'm going to add the opposite signs. So we cancel out on the first one, and then this first term, 0 plus a negative 12, will leave me negative 12x squared. And bring down my next term of positive x. All right, now we're taking x into negative 12x squared. So that would give us negative 12x. And then we're going to distribute that in. So that would give me negative 12x times x is negative 12x squared. And negative 12 times 4 would give me negative 48x. Okay, so we add down by adding the opposite sign. I like to do that thing where I really show that I'm changing it from subtraction. So we're just going to add, no, why does it always do that? Add opposite sign. Good, goodness. Ignore who's flying with me. All right, so x plus 48x gives us 49x. Last step, drop down the -5. So we have 49x divided by x leaves us with 49. So plus 49 up here. Then distributing that out, it's going to give me 49 times x is 49x. 49 times 4 gives us positive 196. And then instead of subtracting, we're going to add the opposite signs. So the 49s cancel out, and -5 plus a negative 196 leaves me with a negative 201. So that's my remainder. And if we're writing this as one big term, we would write this as 3x squared minus 12x plus 49, and that's going to be minus 201 over x plus 4. Which I'm going to write it like this, or subtract that off. Okay. Any questions on this last example? Okay, folks, that's going to do it for today. Like I said, if people have questions, I'm more than willing to kind of stick around and answer any questions that people might have. So, yeah, if you want, I'll stick around and answer questions either about homeworks. If they have any questions about grading stuff, I'll stick around and answer that. If you'd like, I can throw you into if you want to talk about your grade and you want to do it privately, we can go into a breakout room. Or if you just have any questions about material. Otherwise, have a good afternoon, and I'll see you back here tomorrow.
Thanks, Professor.
Thank you.